In this video I will cover Chapter 6. Chapter 6 is entitled Fundamental Networks. Many of the objectives and concepts and terms in this chapter are repeats from your CIS 164 class. Because of this, I will skip over many of these and go through them fairly quickly. But if you have not had the 164 class or need a refresher, I highly encourage you to read through the entire chapter. We use networks every single day whether we realize it or not. Networks affect the way we play, the way we work, the way we learn, and our everyday activities. Think about using a credit card. When you use a credit card to make a payment at a store, that credit card number gets sent over a network. We have mail delivery systems through networks, telephone systems, public transportation systems, corporate computer networks, and the internet. These are all examples of networks that we use on a daily basis. Networks are simply computers linked together so that we can share data and resources. Think of your computer without the ability to connect to a network or the internet. There's not a whole lot you can do on a computer without a network or the internet, besides word process and play games. Types of networks are typically characterized by the type of media used to connect the devices. Is it wireless, wired, or fiber optic? The type of networking devices being used. How the resources are managed. Is it client-server type of model or peer-to-peer? How the network is organized. How the data is being stored, and the area that it serves. Some common terms that we typically see with networks are LAN and WAN. A LAN stands for Local Area Network. This is a group of interconnected computers under one administrative control and typically confined to a local geographic area. If you think of BSC's network would be a local area network. It's under one administrative control, and the geographic area that it serves is the BSC campus. A wide area network simply connects two LANs together. A wide area network is separated by a larger geographic area. If you think about connecting BSC to NDSU, BSC has its own LAN, NDSU has its own LAN, and when we connect those together to make the university system network, we now have a wide area network. With a WAN, we are typically using some type of WAN technology like a T1 line, frame relay, point-to-point link, or fiber optic. Some other characteristics in how we classify networks are peer-to-peer networks or client-server networks. Peer-to-peer networks are easy to set up. We don't need any additional equipment. We typically don't need a dedicated administrator. The downfall with this is we have no centralization. Every single computer is in charge of its own resources, in charge of its own backups, and in charge of its own administration. With a client-server network, we have a centralized server. On that centralized server, we can have centralized user accounts, centralized files. We can back up the files centrally, but we typically need a dedicated server and usually an administrator to administer that server. Bandwidth is the amount of data that can be transmitted within a fixed period of time. Bandwidth is typically a theoretical amount of data that we can send between two hosts. Most of the time this is seen in bits per second. The average connection is about 100 megabits per second. An IP address is a unique number that's used to identify a network device and is represented by a 32-bit binary number. We have 4 octets that make up an IP address. Here's an example, 190.100.5.54. Every single IP address in the world needs to be unique if it is out on the internet. So if your host is connected to the internet, it has to have a unique IP address. This is the address that routers look for to deliver the correct packets to the correct destination. The subnet mask is the second part that goes along with your IP address. When we combine the subnet mask with the IP address, this tells us what network that we are on. The part that's left over after we AND together the IP address and the subnet mask determines the specific host. Take for example the IP address of 192.168.1.1 with a subnet mask of 22255.0. This would tell us that we are on the 192.168.1 network and the specific host that we are is the 1 host on that network. For more information about IP addresses and subnet masks, I encourage you to take a look at the reading or do a quick simple Google search on IP addresses and subnet masks to get a better understanding. To get an IP address and subnet mask, there are a few different ways in which we can do this. One way is to manually assign or statically assign the IP address and subnet mask to the host. The other way is through DHCP, which stands for Dynamic Host Configuration Protocol. With DHCP, your network card will automatically go out to a DHCP server and get an IP and subnet mask for that particular PC. It can also be assigned a default gateway and DNS servers if the DHCP server is set up that way. One quick note about protocols. A protocol is basically a set of rules or a language that governs how communication with PCs on a network is going to work. The most common protocol is TCP/IP. This protocol is required to be on the internet, and this protocol uses the IP address and subnet mask to deliver its data. The most common type of media used in a network today is still twisted pair cabling. With twisted pair cabling, we use electrical pulses to send and transmit our data. Twisted pair cabling is inexpensive and easy to set up. The most common type of twisted pair cabling that we will see is the unshielded twisted pair, category 5, 5E, and now we're starting to see more category 6. Shielded twisted pair is very similar, but we have more shielding inside of the cable to help protect from electromagnetic interference. With unshielded twisted pair, we can get interference and errors on our network from electrical motors, fluorescent lighting, and potentially radio waves. If we need to run our wires by electrical motors through fluorescent lightings in the ceiling, then we can choose shielded twisted pair. It is going to be a little bit more expensive, but it will protect us from that EMI interference. Fiber optic cable gives us tremendous speeds and great distances, but it is a lot more expensive than copper cabling. It's harder to work with, and typically you have to be certified to work with it. So you don't see it a whole lot out there right now, but it will probably become more and more cost effective and more widely used in the future. There are basically two types of fiber optic cable that you should know about: multi-mode and single mode. Multi-mode has a bigger core. Because it has a bigger core, we are going to have more dispersion of our light. This helps for going around bends and twists, but we do not get the distances or the speeds. Single mode fiber has a smaller core. We must keep the cable relatively straight, but because of the smaller core, we can have longer distances and we can have greater speeds with the single mode. Single mode is going to be a little more expensive than the multi-mode fiber as well. When you talk about networking, there are many different organizations that you will hear about. Some of the more common ones are the IEEE and the ISO, also ANSI and TIA, EIA. All of these different organizations were developed to create standards for certain aspects at the physical layer. For example, the TIA, EIA creates standards for voice and data wiring for all LANs. You may have heard about the EIA, TIA 568A and 568B standards to pin out category 5 cable with an RJ45 jack. Without these organizations and standards, we would have chaos with networks. Each individual brand could potentially come up with their own standard and cause some incompatibility with other makes and manufacturers. Having these standards ensures that all manufacturers can communicate with each other because they all have the same standards that they're working with. A common standard for IEEE is 802.3. This is the Ethernet standard that specifies how an Ethernet or wired network is going to work. We use what's called the carrier sense multiple access collision detection type of transmission mode, where all stations on the network will listen on the network wire for clearance, and then they will go ahead and send their data. If a collision happens, we detect that collision and we will resend the data. With Ethernet naming technologies, typically what we see is the speed. In this example, 10 base T, what the 10 means that we can go 10 megabits per second. Base means baseband transmission or digital signaling, and the T means twisted pair. So we have speed, the type of transmission, and then typically the type of technology. So this one here, 100 base TX, 100 means we can go 100 megabits per second. Base means the baseband transmission, and TX means that we're using twisted pair type of cabling. Wireless networks or Wi-Fi is IEEE 802.11. You may have heard about 802.11 B, A, G, and N. G is probably the most common right now at this point in time. It is a ratified standard. We can go 54 megabits per second. 802.11n currently is still in the preliminary stage. They're estimating speeds up to 540 megabits per second and greater distances. You can buy 802.11n networking products currently, but it's not a ratified standard at this point in time. This is a great chart to compare and contrast all the different wireless standards, A through N, and also Bluetooth. Everything besides Bluetooth is backwards compatible, so I can have an 802.11g network card, and I can have that connect to an 802.11n access point or router. The G has a 54 megabits per second speed, the N has 540. If I have a G card connecting to an N access point, I'm only going to be able to go at 54 megabits per second. So everything is backwards compatible, but we're always going to dummy down to the lowest speed. The OSI model is talked about at great length in this chapter as well. I do have a separate video posted on the OSI model. I encourage you to take a look at that. A quick note about a modem. You'll probably see a question like this related to a modem on the A+ certification. A modem stands for modulation demodulation, and essentially what a modem is used for is to transfer analog signals to digital signals or vice versa. When a modem is transmitting, what it's doing is it's converting digital signals that our computer utilizes and converts that to analog signals to be sent typically over a telephone line or the cable infrastructure. When the modem receives signals, it's taking that analog signal and it converts it to a digital signal. This is called demodulation. Our computers communicate with digital signals. We need to take the analog signal from the phone line, convert it to digital signals to be sent to our computer. The POT system, or plain old telephone system, is one type of connectivity that is still widely used today. We use our existing telephone infrastructure to send communication back and forth. DSL is a common type of internet connection that people use. It's an always-on technology that uses the existing copper telephone lines to provide high-speed data communication. ADSL is probably the most commonly used technology. There are some other technologies out there. The ADSL offers speeds of 1.5 megabits per second. Here locally, Quest uses the ADSL type of DSL. The upload speed is a little bit lower than the 1.5 megabits per second, so it's not the best solution for hosting a web server or FTP server. Some other types that we'll see: HDSL, SDSL, VDSL, and IDSL. The best one currently for speeds is the VDSL, speeds between 13 and 52 megabits per second. But the downfall with the VDSL is you have to be relatively close to the source. Powerline communication, or PLC. Powerline communication uses our power distribution grid to send data signals along with our power across the existing infrastructure. This is kind of a newer technology that's still kind of in its infancy. We probably don't see it a whole lot out there right now, but we will start to see it more and more often. Because of the existing infrastructure, we can potentially offer internet connection and data connections to places that previously couldn't have them. A common term that we hear is broadband. Broadband is a technique used to transmit and receive multiple signals using multiple frequencies over one cable. Broadband uses a wide range of frequencies that may be further divided into channels. Some broadband type of connections include cable, DSL, ISDN, and satellite. Broadband type of connections offer great speeds and are typically always-on type of connections. Bluetooth is a very common type of connectivity. Bluetooth is very common because it's supported by a wide range of devices. The speeds really aren't that great with Bluetooth, however, and the range isn't the best. Currently with version 3 and version 4, we're at 26 megabits per second. With version 1, when it first came out, we were only at 1 megabit per second. But it is a good technology because it's widely supported and the connection that it makes to the devices is rock solid. Voice over IP is a method used to carry telephone calls over an existing IP network. Basically what we do with a voice over IP network is we send our voice signals or our telephone signals over an existing computer network instead of using the POTS telephone system. Virtual private networking is a common tool telecommuters will use to connect to their company's head office. The most common type of VPN is creating a tunnel through the internet. Take for example BSC's network. When I'm at BSC and connected to the network, I have access to all of their servers and all of their resources. But when I go home for the day, I am no longer on BSC's network. I'm on my home network. At home, I no longer have access to BSC's resources and their servers. But through VPN, I can create a tunnel through the internet and connect to BSC's network. With that connection, I now have access to all of BSC's resources and all of BSC's servers. To BSC's servers and to BSC's network, it's acting like I'm actually physically connected to their network when in reality, I'm sitting at home. The last part of Chapter 8 goes through troubleshooting networks. Our steps still have not changed for troubleshooting networks. We still want to identify the problem. Ask your open-ended and closed-ended questions, get as much information as possible, find out what has recently changed, and see if you can find the exact problem. Step 2 is to establish a theory of probable cause. Create a list of the most common reasons why the error occurred. Typically with networking, it's a physical layer problem, meaning that there's a loose cable connection, you're not properly connected to the network, or you're losing connectivity. Step 3 is to determine the exact cause. Once you found the exact cause, try to implement the solution. Once the solution is implemented, verify it and have your user verify system functionality. Some common tools to verify the solution and system functionality are the ping command. Ping command will send packets to a destination to see if we have network connectivity. NSLOOKUP is to check DNS settings. Traceroute is to trace the route our computer takes to get to a destination across the network. And NetView is used to display a list of computers in the network. Great tools to use to verify solutions and also to do troubleshooting to pinpoint the exact cause of the problem. Step 6 is to document our findings again. We don't want to reinvent the wheel. Put the problem description, your solution, any components used, and the amount of time spent to solve the problem. That way, if you get a similar problem, you can simply pull up this document and you can find your solution to the problem, how long it took you, and any components that you needed to use. That is all for this video on Chapter 6. Thanks for watching.